so this is section 3.1 and section 3.2, and it's about types of energy and also how to transform one type of energy into another. Some of this you learned through your Kahoots the other day, and you showed me you already understood some of it, which is great. Okay, however, we do want to make sure that everybody understands it all, so we will go through it again. This particular PowerPoint is only 8 slides long, and then we'll get to the next one with some videos. Good afternoon to you too, lovely students. Okay, so there's lots of sources of energy, like where the energy comes from in the first place. That was section 4. Okay, so you had solar, wind, geothermal, nuclear, biomass, and whatever the other one was. Okay, so these are different types. So this would be output. Okay, chemical energy can be like the groceries, the crackers and cheese and sausage and olives and grapes you just ate for lunch. It can be batteries, right? So inside a battery, there's a chemical paste, which we'll talk more about in section 1. Okay, that's called an electrolytic cell. Okay, so normal people call those batteries. In science, we call them cells. Okay, but you're like, well, didn't we learn plant cells and animal cells last year? Yeah, but these are electrical ones. Okay, so there's chemical energy. Solar energy comes from the sun, solar panels, right? And then we have something called gravitational energy. Sometimes we also call that potential energy because it has the potential, the ability to make something happen. So if you are holding a watermelon up high, and it has what's called potential energy, because if you let go, it's going to fall down and smash all over the floor. Okay, so as it's falling, anything that's moving is kinetic energy. Okay, so the most common example of transferring kinetic energy and potential energy back and forth is a pendulum. Okay, so like think of a swing. You're on a swing set. When you're at the very top, you're kind of stopped, right? You're not moving anywhere. And if you need me to screen capture your chat, I'm welcome. That's fine. Okay, so at the top of the swing, you have lots of potential energy. Okay, you have the ability to let gravity pull you down. At the bottom, you're going as fast as you're going to go. Okay, so you have highest kinetic energy at that particular point in time. Okay, and sometimes we call mechanical energy the energy of movement as well. Electricity has to do with electrons flowing. See that word, electron, okay, flowing. So in this case, we're taking gravitational energy from our waterfall, from our dam, from our reservoir, down, thank you gravity, spinning the turbine. That makes mechanical energy, which is converted to electrical energy. Okay. Next, this is a different type of mechanical energy that we discussed when we were talking about wind. You're trying to get something else to do the work, right? We want free energy, so we don't have to pay money because it's cheaper. And we can buy other things like video games and sports lessons and shoes that cost $400. And so we want something to do the mechanical aspect of creating our energy. So in a wind turbine, that spins the blades, okay, which turns the shaft, and the generator, okay, this little bit here, makes the electricity, okay, and it's transferred down the pipe and out to the power lines. Thermal, luckily we learned that word a couple times already, grade 7 and onwards. Thermal has to do with heat. Okay, so in this particular case, and in a toaster, you have electricity coming from the wall, right? Plugs into your toaster or your heater, and it runs electricity through wires that heat up, and they're called resistors. So certain elements we want to have high resistance. We want the electrons to flow through. We want them to give off heat, okay, like a toaster, like a heater. Other things we don't want them to give off heat, like a light bulb. Okay, the old-fashioned incandescent light bulbs were very inefficient because a lot of the heat was created by the electricity going in, whereas we only wanted light energy. Okay, so lots of different types of energy. So far we've got chemical, solar, right? Light energy would be another one for that, another word for that one. Gravitational, electrical, mechanical, thermal. And so here's another picture for mechanical energy. It's the energy of motion. And we have nuclear energy. So if you smash particles together, okay, neutrons into uranium, you can cause fission. Fission means to split. Fusion is to squish together, right? Like melting, fusion. Fission is splitting. So when you split apart atoms, you release quite a bit of energy. Then there's sound, which we don't really talk about in grade 9. Okay, so this is what I was talking about earlier with the toaster. Okay, so what energy is going in? Your energy source is electrical energy. So that energy could have come from solar power. It could have come from wind energy. It could have come from burning coal. Okay, but however you produced your electrical energy, you're putting it in the wire, and what you want is thermal energy. You want the heat. Okay, in this one, you have a battery. Okay, this is what they call the iPod. Okay, before fancy iPhones. You might still have some in your house. So in an iPod, you had a battery. So in your phone, you have chemical batteries that can be recharged until your phone dies. Okay, and that converts in the phone to electrical energy, and then you can either get sound or light or music or whatever you need to come out of your phone. Okay, in this one, this is called a drill, so electricity goes in and it makes the drill bit spin. That's mechanical energy transformation. Okay, so if you were to guess how we get what the input and output were of this picture. Okay, I'd like you to leave your mute on, but you can answer. Okay, so what is going in? Electricity, good job. Okay, what forms of energy are coming out? Light, yep, and also heat. We don't want the heat, but that's part of it. Okay, energy input here. You have chemical energy in your batteries. Okay, and that's going to go in your super awesome RC car and makes the wheels spin. Mechanical energy. Okay, this one is the same as that one, right? Electricity in, heat and light out. This one is totally designed just for heat. That's a blow dryer, right? Electricity in, thermal energy out. Next, we're moving on to thermocouple. Okay, this is a pretty old school picture. And as you know, I'm not really into old school pictures. I like videos. Okay, so we're going to bust out this thermocouple one.
Maybe you didn't already know. This is a copper wire, and this is an iron wire. When I twist the ends of the two wires together and then heat them up in a flame, an electrical voltage is produced. Now, not a very big voltage, mind you, but it's a voltage just the same. Now, I guess if I had enough of these copper and iron junctions and heated them up in a big bonfire, I could produce enough electricity, perhaps, to run a machine. In fact, that's how some space probes generate electricity. This is a picture of the Cassini probe, the one that explored the rings of Saturn. The energy from long-lasting radioactive isotopes, heated up a bunch of metal junctions, and those junctions, through the thermoelectric effect, provided the electricity needed to run the onboard radios. Okay, let's test it out. I've attached the ends of the wires to my voltmeter. Right now, the voltmeter shows that no voltage is being generated. Now, I'm going to hold the junction of the thermocouple in the candle flame. So, I need to light the candle. I'm going to push the junction into the candle flame and let it heat up. Look, already a voltage is being generated. The hotter that thermocouple gets, that is, the hotter that junction gets, the more voltage is produced. When I remove the junction from the flame, you can see the voltage goes away. In the flame, voltage, no flame, no voltage. That's the thermoelectric effect.
Okay, so that was also a grade 7 concept, but that's okay if you didn't learn it back then. And you might think, well, who cares about the having two wires create electrical current? Okay, but that's how you measure how hot your oven is, right? It kind of, I don't know about you guys, but sometimes we use our ovens for cooking. Like yesterday, we had made Brussels sprouts in the oven, and you might think, ew, gross, but they're delicious. You put bacon and garlic and olive oil on them, and they're delicious. And so it matters if your oven is 300 degrees or 400 degrees. So we can't put a thermometer in there, right? The alcohol in it, it's not, that red stuff isn't mercury, it's alcohol. Okay, the red stuff, that would boil, right, in the oven. So you can't use that to measure how hot an oven is, but you can use a thermocouple. Okay. There we go, done thermocouple. Now let's find that other PowerPoint that I put somewhere. There it is. Okay, so what is energy? And it said in one of those videos, energy allows work to be done. Okay, and as we learned in grade 8, work is force times distance. So if there's nothing happening in terms of force, then there's no distance happening. Okay, what's going on with electricity? Electrons are giving up energy to different devices, and those different devices we're now going to call a load. Okay, so we're not just going to call it a toaster, we're going to say that's an electrical load. So the resistance in the wires that make them heat up hot to cook your toast, okay, that is called a load. So a resistor is anything that makes it difficult for electricity to flow. Okay, again, we'll talk more about that in section 1, but it's good to learn these words early. Okay, so lots of appliances like ovens and hair dryers convert electricity to heat on purpose. Okay, you have a curling iron, you have a straightening iron, you have those hair wand things, of course, everybody does, right? And they are designed like that on purpose. Other things we don't want to release heat, like your phones. I don't know about you, but my old phone, the screen would get really hot after a while. I think it was broken, okay, at some point. And like I'd try to text and it would burn the edges of my fingers, right? So we don't want that. Some devices we want to heat up, other ones we don't. Okay, and here's some words for how thermocouples work. Okay, 2 different metal wires, and it lets electrons flow through them, making electricity. Okay, so here's 2 dissimilar metals, hot and cold. Okay, and if we're getting fancy, we call it a thermopile. Okay, but mostly I just want you to understand that a thermocouple is using 2 wires to increase the voltage or create a voltage. So this is a fancy one about electricity to motion called the piezoelectric effect. You can learn more about that in Mr. Bohachev's physics class. But I would like to switch to generators though. Okay, when we're talking about changing mechanical energy to electrical energy. Okay, so back at school, we have this lovely little doodad, okay, where if you spin the handle, it makes electricity, which you'll notice it light up with the little light bulb. Okay, watch this. You can turn mechanical energy into electrical energy by turning the handle, and this light bulb, the load, will light up. And this, the more energy you're using, so the more electricity you're going to get. You can also take electrical energy from our friend the battery. This was really neat. I just tried it to see what it would do. And if you plug in the battery without spinning the handle, find out what happens. 6 volts and make mechanical energy. Convert, not make. Convert. Are you ready? Ready? Here we go. Whoa. Mechanical to electrical, and electrical to mechanical. Okay, so you can't see the handle spin. There you go, now you can. Okay, so those are our generators, and when we get back to school, I will dig them out, and we can sanitize, and you can try them. Okay, I have to pause my recording.